Physics Part 124. Pressure is defined as force per unit area, where force F acts perpendicularly to the area A. P is equal to F over A. The symbol for pressure is P and its SI unit is the Pascal, PA, which is equal to 1 Newton per square meter, Newton per meter. Column of liquid above the area A. The link between pressure and density comes when we deal with liquids or with fluids in general. Consider a point at a depth h below the surface of a liquid in a container. What is the pressure due to the liquid? Very simply, the pressure is caused by the weight of the column of the liquid above a small area at that depth, as shown in the figure 6.19. The weight of the column is W is equal to mg is equal to PAHG, and the pressure is W over A, which is equal to PGH. P is equal to PGH. The pressure is proportional to the depth below the surface of the liquid. If an external pressure such as atmospheric pressure acts on the surface of the liquid, this must be taken into account in calculating the absolute pressure. The absolute pressure is the sum of the external pressure and the pressure due to the depth below the surface of the liquid. Example: calculate the excess of the pressure over atmospheric at a point 1.2 m. Below the surface of the water in a swimming pool, the density of the water is 1.0 into 10 power raised to 3 kilogram per meter cubic. This is a straightforward calculation from P is equal to PGH. Substituting P is 1.0 into 10 cubic into 9.8 into 1.2 is equal to 1.2 into 10 power raised to 4 Pascal. If the total pressure had been required, this value would be added to atmospheric pressure PA. Taking PA to be 1.01 into 10 power raised to 5 PA, the total pressure is 1.13 into 10 power raised to 5 PA Pascal. Now it's your turn. Calculate the difference in blood pressure between the top of the head and the soles of the feet of a student 1.3 meter tall, standing upright. Take the density of the blood as 1.1 into 10 power 3 kilogram cubic meter. Upthrust. When an object is immersed in a fluid or liquid or a gas, it appears to weigh less than when in a vacuum. It is easier to lift large stones under water than what they are out of the water. The reason for this is the immersion in fluid provides an upthrust or buoyancy force. We can see the reason for the upthrust when we think about an object such as cylinder in figure in water. Remember that the pressure in a liquid increases with depth. Thus, the pressure at the bottom of the cylinder is greater than the pressure at the top of the cylinder. This means that there is a bigger force acting upwards on the base of the cylinder than there is acting downwards on the top. The difference in these forces is upthrust or buoyancy force, FB. Looking at the figure, we can see FB is equal to F up minus F down. And since P is equal to PGH is F over A, FB is equal to PGA H2 minus H1 is equal to PGAH is equal to PGV, where H is the length of the cylinder, V is its volume, and the upthrust is simply weight of the liquid displaced by the immersed object. This relation has been derived for a cylinder, but it will apply to the objects of any shape.